He asked me if I wanted to start writing for their PTC Mathcad blog, and in my first pitch meeting, I threw out an idea. It was coming up on the NFC AFC Championship game for NFL. My beloved Eagles were in the game, and I said, hey, you know what? I think there's a relation between the coin toss and the outcome of the game. And they said, oh, Dave, you're crazy. The coin toss is random. There's no way that the coin toss can be correlated to the outcomes of the NFL championship game. But they said, go ahead, run with it, see what you find. And I did find some interesting results, which are documented in the blog. And my results have actually held up for the past two Super Bowls before the end of the game. I was able to take a look at the predictions and say, hey, this means the Eagles, well, it doesn't mean the Eagles will win, but the data shows that the Eagles are favored to win in Super Bowl 52 and the Patriots are favored to win in Super Bowl 53. So in order to do this, I created an Excel spreadsheet. I went back all the way to Super Bowl 1 and dug up the data on which was the visiting team, what was the call made during the coin toss, what was the result, who made the call, who won, who lost, who won the game. And also noted some things about in 2008, there was a rules change in that changed how the coin toss worked. But anyhow, I have this Excel spreadsheet and I want to analyze it in PTC Mathcad. So let's take a look at doing that. All right, here I am in Mathcad. I know I'm going to read in that Excel spreadsheet and I'm going to take a bunch of different columns and turn them into matrices and vectors. And first, I'm going to set up something called the origin. And if there's a special keyword in PTC Mathcad, if you type in origin and then evaluate it, it shows that it has a value of 0. So the first column and the first row have the numerical identifier of 0, but for simplicity, I want to use a value of 1. So I'm going to type in origin, and then I'll use my equal sign. If I go to the operators, I always like to use the global definition for origin. And even though I'm doing this at the beginning of the sheet, I always like to do it this way. So I'm going to set the origin equal to 1. And there you see the calculation updates. This global definition means that even if origin is used higher up in the worksheet, it's going to take on the value throughout the entire worksheet. Next up, it's time to read in the Excel file. To do that, I am going to go to the Input-Output tab, and here we have a Read Excel function. I will click the Browse button, and here is the Excel spreadsheet. Let me click the Open button. And right now, it's going to bring in, let's make this a bit wider, it's going to grab columns A through L. And I actually don't need the A column because that's just a number of which Super Bowl it is. I'll start with the B column, and I don't need the J, K, and L column, so let's change this to column I. And for the rows, I don't need the header row. Let's just grab row 2 and scroll down here. I only need through line 54. So this is good. Let me click the Insert button. And so here I have my Excel function. Let me grab it and move it over a little bit because what I want to do is now assign this to a variable. So I position my cursor to the left of the function, and then I can use the assignment operator, which is the colon key on the keyboard, and I'm going to assign this to the variable coin toss. That is good. And if you want to verify that, we can type in the name of the variable, coin toss, and then equals to evaluate it. And here we see the different columns in here. So the first column, this is for the visitor conference, and this is what the coin toss was called. This is the actual result. Then we have the toss winner and all these other different things in here. So let's get rid of this. I no longer need this evaluation. And let's take the different columns and extract them from this variable. So first off, I'm going to extract the visitor conference, and that is going to be equal to coin toss. And now I'll go to the matrix and table operator, and from this drop down, The second one in here is the matrix column operator, which will return a column from a matrix and then assign it to this. And the first column is for the visitor conference. I'm going to do that a few more times to extract some different values out of here. Let's create those. Coin toss call is going to be equal to, oops, yeah, that's good. That's going to be equal to coin toss. And if you go to the drop down over here, you can see that the shortcut is Control-Shift-C in order to get to this. So I can choose Control-Shift and then C. Oops, let me get out of here. Control-Shift and then C. And then we have the column operator, and that is the second column. Let's create a variable, a vector for the coin toss result. That's going to be equal to coin toss, and then Control-Shift-C. And the third column, I'm going to do this a couple more times to extract the results of the toss winner and the game winner. So the toss winner, oops, can't spell. All right, and the game winner conference. That's going to be equal to coin toss, Control-Shift-C, and that is in column 8. So that way I've got a bunch of different vectors in here. Let's now do some basic analysis. For one thing, I will need to know the number of games that are in here. So let's create number games. That way, if I ever update my spreadsheet, then this will update. And so there is a function called rows, and I will pass the coin toss vector or matrix to it. And yep, there have been 53 of those games so far. And now let's take a look at writing a program. And so one of the interesting results that I found was that the visitor seemed to win more than the home team did. So the visitor is the one that gets to make the call during the coin toss. So I wanted to count how many times the visitor would win. So let's create a program to do that. And the program, I'm going to call it visitor wins, and it's going to take in two different values, and so it's the visitor matrix or vector and the winner matrix. And let's use our definition operator to create the program. I'm going to go to the Math tab, and here we have programming, and a program is basically a custom function that you end up creating. So let's start it out here, and inside of this program I'm going to use a counter variable to basically count the number of times that the visitor has won. Let me go to the programming, and here is the local assignment. This is how you assign values inside of a program. It's not going to be the regular assignment operator, definitely not the evaluation operator, it's the local assignment. And so that counter is going to start out as at a value of 0. And now we're going to do a loop to process through the data. Let's create a for loop, and beware that you can't just type in the letters FOR. You either need to use the command from the programming dropdown or use the keyboard shortcut of Control-Shift and the single apostrophe. And so for this program, we need to have a variable that is going to count things. So I'm going to use just variable I, and this is going to go from 1 ... range variable to the number of games. So we're going to cycle through the entire matrix, and then I'm going to do an evaluation. Let's go to the programming, and we're going to evaluate if the visitor and then we want to go to the matrix and table. And so in this case here, if we want the index, if visitor sub I is going to be equal to, and let's go to input output, the math tab, programming, actually operator. We're going to evaluate if, here is the comparison operator. If the visitor is equal to the winner sub I, then we are going to increment the count variable. So count is going to be equal to count plus 1. And this is good for the loop. And let's position the mouse over here, hit the enter key, and let's go to programming. We want to return the value of the count. So this is going to perform our function, our evaluation. Let's take a look at the result of this. I'm going to create a new variable, visitor wins, and that's going to be equal to the function. And the two matrices that I'm going to pass to it are visitor conference and the game winner conference. And hit the equals to evaluate. And so we see that the visitor has won 32 times, 32 out of 53 games. So that is definitely an advantage to being the visiting team when you are going into the NFL championship game. So that's one of the first really surprising things that I found by taking a look at this. So for example, if we just wanted to see what that turns out to be, that's over 60% of the time the visitor team has won. And if we take a look, we would expect, roughly 50-50. And so this is actually, if you take a look at the standard deviations for this, let's go ahead and do that. So for example, we know that let's say we're going with a simple probability of 0.5. And I'm just going to create a variable, coin flip probability colon equals, that's going to be 0.5. And so we could take a look at the mean value, which is that's going to be equal to the number of games times the coin flip probability. The one downside of me using such long variables is that it takes me a long time to write these different lines in here. And now let's calculate what the standard deviation is going to be. So I'm going to abbreviate that, standard deviation, and that's going to be equal to, let's go to our operators. It is going to be the square root of the mean value times 1 minus the coin flip probability, which again is just 0.5, but again, I like to use variables. And let's hit the equal sign. So standard deviation is 3.64, and so we take the mean number, 26.5, and we add, let's say 7.2 to it, that comes out to 33. It's almost 2 standard deviations above what would be expected for the visiting team to win the game. Now let's take a look at how many times the coin toss winner has won the game. So let me go to the bottom of the sheet here and go to a new page, and let's write another different program in order to do this. And I'm going to call this the toss winner wins game. And it's going to take 2 variables, toss and winner, 2 vectors actually. And let's start off our program. And this one, again, we will use a local variable called count, and we're going to start it out at a value of 0. And then we're going to write another for loop to process the data. Let's do for, and we'll use that same variable I. Is going to go from a value of 1 ... to the number of games. And then we will do our evaluation. So we'll say that if, and then toss. And for the, again, if you go to the Matrices and Tables tab and then Vector Matrix Operations, here is the matrix index, which is the same thing as the left bracket on the keyboard. And so if toss sub I, and use the space over here, let's go back to the Math tab, and for the operators, here we have comparison if that is equal to, and we're going to say winner. And this time I'll use the keyboard shortcut of the left bracket, sub I. Then we are going to increase the count. So count is going to be equal to count plus 1. And let me position my mouse over here to get out of the for loop. And once again, we're going to return the value of that counter variable count. So that's good. That is my second program inside of here. Now let us pass on the values here. So I'm going to create another variable, toss winner wins game. Is going to be equal to this function. Again, I use really long names. And the two things that we're going to pass to it are the toss winner conference and the game winner conference. And now, just because I've gone to the end of the sheet here, I'm just going to evaluate it on a different line. And so we can see, all right, the team that wins the toss has won 25 times. And so that means that there's a slight advantage to losing the toss. And so let's see if we do, let's see, number of games minus TWWG. That's going to give us the, oops, hit the wrong button. Let's divide this by number of games. And then evaluate this. So 52.8% of the time, the team that loses the coin toss ends up winning the game. So again, it's another little, surprising result. It's not above, outside of a standard deviation, but it does show that, there's a slight bit of an advantage to not winning the coin toss. All right, let's take a look at a few other interesting things. If we go back to that spreadsheet, a few interesting things here. If I take a look at the last 6 games, the NFC has won the coin toss. And another interesting thing that happened is that there was a stretch of 14 years in which the NFC won the coin toss. That's, unusual. We can see what the binomial distribution of those different results have been. Let's see some other different things. There is a streak of some heads and some tails in there. Of course, it's random. It's, to be expected, but we could see what the binomial distribution of those different events are. So, for example, let's take a look at the fact that the NFC has won 5 of the last 6 tosses. There is a function that I happen to know is, oops, bad at typing today, the binomial distribution, and we say that it's won 5 out of the last 6 games, and there's a 50% probability that you could, 5 out of the last 6 coin tosses, there's a 50% probability of that. So if we evaluate that, there is basically only a 10% chance of something like that happening. And let's take a look at the possibility of getting the coin toss 16 times in a row. Let's do the same function, and of getting the same result 14 out of 14 times with a 50% probability on the coin toss, we can see that that is a really, really low number over here. And if we want to change the formatting of this result, you could go to the Math Formatting tab, and right now it's set to General. We could change this to decimal, and let's change the number of decimal places out. Let's see if 6 decimal places. There you can see it's like, yeah, the chance of randomly winning a coin toss 14 times in a row is really, really low. This ends up being, wow, just like 0.006%, 0.006% chance of that kind of result happening. And one other thing that is interesting to take a look at is how many times the NFC has won the coin toss at all. And to do that, let's create another variable, NFC wins toss. And that I'm going to say is going to be equal to the rows function, which we used earlier to count the number of games. And this time inside of the rows function, I'm going to call the match function. And let's see how many times NFC appears in the toss winner conference. And evaluate that. So we see that 35 times. The NFC has won 35 times. And we can see that, that's significantly above a standard deviation of that we calculated earlier. Again, standard deviation of 3.6, mean value of 26.5. We can see that that result is over 2 standard deviations higher than what you would expect. So again, just some interesting numbers that we can get out of taking a look at the coin toss results. And I will put that spreadsheet on my Dropbox on my website if you want to evaluate any of this data for yourself. And again, big reminder, PTC Mathcad Express is available for free. Anyone can download it and start using it for doing engineering calculations or sports calculations like I have done here. I hope you enjoyed this video. For more information, please visit www.creowindshield.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button to be informed when new videos are uploaded. Thank you very much.